Dear students, last time we discussed Fourier series of a function of period 2 pi. Now we generalize this thing. We consider a periodic function of period 2L and generalize the theory discussed in last lecture. Functions of period 2L. L is positive number. Now we convert the Euler formulas, that is the formulas for A0, AN and BN using change of scale property and get the Fourier series for such functions. Okay, so consider the function f of x having period 2L using change change of scale property in the integrals. Okay, change of scale property in the Euler formulas the Fourier series of f is given by f of x equal to a0 plus summation an cos n by x by l. Change is n by x by l plus bn sin n by x by l. N from 1 to infinity, where a0 is now given by 1 upon 2L integral from minus L to L f of x dx. Okay, so in the earlier definition we use change of scale. Then we have an to be 1 upon L integral from minus L to L f of x into cos n by x by L dx, and bn, here n is 1 2 3 and so on, and bn is 1 upon L integral from minus L to L f of x into sine n by x by L dx. Again n is from 1 2 3 etc. Okay, Now we solve examples using this theory. Example 1. Find Fourier series of function f given by 0 if minus 2 less than x less than minus 1. Its value is k. K is constant. If minus 1 is less than x is less than 1, and it is 0 if 1 is less than x less than 2. F is periodic function of period, and f is periodic function of period. To L, that is 12, here period is 4, 12 equal to 4. K is constant. Okay. So this function looks like, so this is horizontal axis, that is x axis. Between minus 2 and minus 1, it is 0. So function is 0 here. Then it is, of course, it is not defined at endpoints. Then its value is k. Any constant, let us take some positive constant. So between minus 1 and 1, its value is, say, this one. And again it is 0 in this open interval 1, 2. Okay. And things will repeat. That means we can have here 3, 4, 5, etc. Okay. Now this part, that means from minus 2 to plus 2, will repeat again. That means between 2 and 3 it is again 0. 3 and 5, its value is k, and 5 to 6 it is 0. Okay. So this will repeat on right hand side as well as left hand side. This function is defined on real line, okay, except at some points. Now let us find Fourier coefficients. Okay, solution. Here, sorry, here 2L is 4 means L is 2. We have Fourier coefficients A0 by definition it is 1 upon 2L integral from minus L to L f of x dx. So this is 1 upon 2L means 4 integral uh, from minus 2 to plus 2 f of x. But note that the non-zero value is only in the interval minus 1 to 1. So without loss we may write here minus 1 to 1. Value is k, dx, so that this is k by 4 into x, limits are minus 1 1, so it is 2k by 4, that means k divided by 2. Similarly, we find an by definition it is 1 upon L integral from minus L to L f of x cos n by x divided by L dx. That is L is 2, so 1 half integral from minus 2 to plus 2, but we know that non-zero values of non-zero value of f is in the interval minus 1 to 1 only. So we write minus 1 to 1. The value of function is k into cos n by x divided by L. L is 2 dx. It is easy to integrate. This is k is constant, so this k by 2 integral cosine, so it is sine of n pi x by 2 divided by n pi by 2, limits are minus 1 and 1. So this is equal to k upon n pi. This 2 gets cancelled. Now it is sine, we put x equal to 1, so that sine n pi by 2 minus, lower limit is minus 1, so sine of minus n pi by 2, and we know that sine of minus theta is minus sine theta, so sine of minus n pi by 2, so this becomes 2 times, okay, so 2 times k upon n pi sine n pi by 2, okay. So this is required coefficient. Of course, we can have particular values if this n is even number. For example, if n is 2 4 6 etc., then this will be signed of some integer into pi, okay. For example, sin pi, sin 2 pi, sin 3 pi etc., and all these values are 0, okay. So therefore an is 0 if n is even. Then we have some positive values and some negative values, okay. For example, we know sin pi by 2 is 1, sin 3 pi by 2 is minus 1 etc., okay. So uh, we can have this as 2. If it is 1, then we have 2k upon n pi, and in this case our n will be 1, okay. So for pi by 2 sine is 1, then 5 pi by 2 it is again 1, then 9 pi by 2 and so on, okay. So if n equal to 1 5 9 etc., okay, there is gap of 4, and it is minus 2k by n pi for other values of n. That means if n is odd but it is not among these numbers, that means 3, 7, 11, etc. Okay. Now next thing is bn. Bn by definition it is 1 upon L integral from minus L to L f of x sine n by x by L dx, and this is L is 2, so 1 half. Function is non-zero in the interval minus 1, 1. So we write here minus 1 to 1. Note that L is 2, so integration should be from minus 2 to 2, but function is 0 in some in other part of that interval. Okay, so this is k times sine n by x by 2 dx. Now we simplify. So this is k by 2. Now integration of sine is minus cos. So minus cos n pi x by 2 divided by n pi by 2. Limits are minus 1 and 1. So this becomes minus k upon n pi into cos of n pi by 2 minus cos of minus n pi by 2. Now we know that cos of minus theta is same as cos of theta. So this is cos of minus n pi by 2 is also cos of n pi by 2. So this is 0. Okay. So we have all the Fourier coefficients. Therefore, Fourier series of f is a0 plus summation n cos n pi x by L plus bn sin n pi x by L. And from 1 to infinity. So this is a0. A0 is 2k upon n pi sine n pi by 2. Sorry, a0 is k by 2. A0 is k by 2 and this is an. So k by 2 plus summation n is 2k upon n pi sine n pi by 2. So this is constant an. So n multiplied by cos n pi x upon L. L is 2 and bn's are 0. So this is required answer. Let us solve one more example. Find Fourier series of function f of x equal to 1 minus x square for minus 1 less than x less than 1. F is periodic function of period 2. That means the behavior of function will be same as this interval minus 1 1. Okay, so it will repeat periodically. F is periodic function of period to L equal to 2. Solution. So we have L equal to 1. Now we find Fourier coefficients. First thing is A0, which is by definition 1 upon 2L integral from minus L to L f of x dx. So this is L is 1, so 1 half integral from minus 1 to 1. F is 1 minus x square dx. So this is 1 half into, this is x minus x cubed by 3, limits are minus 1 and 1. So we have, if we put 1, then it is 1 minus 1 by 3 minus, we put minus 1, so it is minus 1 minus, if it is minus 1, then it will be minus 1 by 3. So we have plus 1 by 3. So this is 1 half. We have 1 plus 1, that is 2, and then minus 1 by 3 minus 1 by 3. So 2 minus 2 by 3. So this 2 gets cancelled and we have 1 minus 1 by 3. So it is 2 by 3. This is A0. Now we find other coefficients. An is 1 upon L integral from minus L to L f of x into cos n by x by L dx. So L is 1. So we have integral from minus 1 to 1. F of x is 1 minus x square cos n by x dx. Okay. So we use integration by parts. Okay. So first term is 1 minus x square. Integration of cosine, it is sine n by x divided by n by, limits are minus 1 to 1, minus integral derivative of first term, that is minus 2x, into integral of second, that is sine n by x upon n by dx. Now if we put upper limit here, then we have 1 minus 1, that is 0. Similarly, if we put lower limit, then minus 1 square, it is plus 1. So again we get 0. Okay. So this term, first term is 0. Okay. Now here we have minus minus plus. So we have 2. N pi is also constant in the denominator. So this is minus 1 to 1 x into sine n pi x dx. We need to use integration by parts once again. So this is 2 upon n pi into first term x integral second, it is So first term is x integral, second it is minus cos, so here it is minus sign, cos n pi x upon n pi. Okay, limits are minus 1 1 minus integral derivative of first term, that is 1, integral of second term. So here I am writing plus sign and using cos n pi x upon n pi dx. Okay, now this is 2 upon n pi. Here again we have n pi, so n square pi square. Okay, then yeah, we take minus sign also outside, so minus 2 upon n square pi square, and then we have x into cos n pi x, limits are minus 1 and 1. When we put upper limit, we have cos n pi minus lower limit, x is minus 1, so this is plus cos minus n pi, but we know that cos of minus theta is same as cos theta. Okay, and second term, so plus it is 2 divided by here n pi and n pi, so n square pi square. Now integral cos n pi x, it is sine n pi x upon n pi, limits are minus 1 1. Therefore we have this as, now cos of n pi is minus 1 raised to n. Okay, this is also minus 1 raised to n, so we have minus 2 into 2, so minus 4 into minus 1 raised to n divided by n square pi square. And here when we put upper limit, then it is sin n pi, sin n pi is 0. Similarly, when we put lower limit minus 1, sin of minus n pi, it is also 0. Okay, so this is the required uh, coefficient. Now we find Fourier coefficient Bn in the similar manner. Okay, so and we have Bn Bn is given by 1 upon L integral from minus L to L f of x into sine n by x by L dx. So it is L is 1, so we have integral from minus 1 to 1, f of x is 1 minus x square into sine n by x dx. Okay, so integration by parts, it gives first term integral of second sine, so it is minus cos n pi x upon n pi, limits are minus 1 and 1, minus integral derivative of first thing is minus 2x, integral of second is minus, so this becomes plus cos n pi x upon n pi dx. Again, when we put upper limit, this is 0, lower limit again it is 0. Okay, so first term is 0, and here we have minus 2 upon n pi, and we use again integration by parts. Okay, so first term is x integral of second, that is cosine, integral of cosine, it is sine n pi x upon n pi, limits -1 to 1 minus integral derivative of x is 1, integral of cos is sine n pi x upon n pi dx. So this is okay. Now first term, we have minus 2 divided by n square pi square, okay, into this. Again, when we put n equal to 1 or -1, it is sine n pi or sine minus n pi. So it is 0. Okay, so first term is 0. Okay, now this is minus, so it becomes plus 2 upon n square pi square. Now integral sign, it is minus. Okay, so -1 into cos n pi x upon n pi. Limits are -1 and 1. Okay. Now this is okay, cos of minus theta is cos theta. Okay, so this will be 0. Okay, let us see. So we have minus 2 upon n cube pi cube into cos of n pi minus cos of minus n pi, and we know that cos of minus theta is cos theta, so this is 0. Okay, so all bn's are 0. Okay, therefore Fourier series is a0 plus summation an cos n by x by l plus bn sin n by x by l, n from 1 to infinity. Now all bn's are 0. So this is a0. A0 is 2 by 3, is it? A0 is 2 by 3 and an's are this we can write -1 into -1 raised to n, that is -1 raised to n plus 1. So we have 4 into -1 raised to n plus 1 plus summation 4 into -1 raised to n plus 1 divided by n square pi square into cos n by x. N is from 1 to infinity. Okay, so this is the required solution. Thank you.